This video is to remind you of all your trig identities. So the top 6 are called your reciprocal identities. I call them reciprocal buddies. So you're going to remember the SNC, CNS. So you've got sine and cosecant, and then cosine and secant, and then vice versa. Cosecant is 1 over sine, and secant is 1 over cosine, and then tangent's 1 over cotangent, and cotangent's 1 over tangent. Okay. You also know that tangent is y over x, so it makes sense that tangent is sine over cosine because sine is y and cosine is x, and cotangent is backwards. Cotangent is cosine over sine. All right, Pythagoreans, sine squared plus cosine squared equals 1. That's sort of the foundation. And then these two, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. And remember, you can move these around. So like I could have 1 minus cosine squared, and you would need to know that that's sine squared. Or I could have cosine squared minus 1, and you would need to know that that's negative sine squared. I could have secant squared minus tangent squared. And really, when the squares pop up, that's what makes you think to go to your Pythagoreans. And then you're going to remember, oh yeah, secant and tangent are related in the Pythagoreans. And so you're going to write this out and then see if you can wiggle it around a little bit to create this. So that would equal 1. So just remember that these 3 exist and that you can maneuver them. Odds and evens we don't use that often, but they do exist. And as soon as I tell you not to worry about it, one's going to pop up. So your 2 evens are cosine and his buddy. So cosine of negative 30 degrees is the same thing as cosine of 30 degrees. And if you think about your unit circle, cosine of 30 degrees and cosine of negative 30 degrees would both be root 3 over 2, positive. So those 2 are your evens, and then everybody else is odd, and it takes the negative from the angle and kicks it out front of the trig. And again, those don't happen that often, but don't throw them away completely. Okay, so, and again, these are from your notes, and I'm just going to cruise through these. This is a refresher course, so if you need to stop and pause or rewind, please feel free. So on this one, and I am going to lose my x's and my thetas just because I'm going fast. That's poor notation. On the AP exam, you cannot do that. But just for this, just to get through it, I'm just going to go quick. Cotangent is cosine over sine, and those cancel. And you've also got to remember your algebra, what you can and cannot do. If you remember when we did this, we had a bag of tricks that we wrote on the board, things like common denominator, Pythagoreans, same change flip, factoring, all these little algebra things, tools that you've learned along the way are all fair game. So really, calculus is a culmination of all the building blocks that you've been putting in place since you started your mathematical career, which I guess is in kindergarten. Tangent, sine over cosine, cosecant, that starts with a C, so that would be 1 over sine. Those cancel. I'm left with 1 over cosine, which I know is secant. Tangent is sine over cosine, cotangent, and that's a 1. And if I had looked up and really looked at this, I know that cotangent is 1 over tangent, and they cancel. And that's not seeing the forest for the trees. So that's, I just made a wonderful, not mistake, because we ended up the same place, but we don't want to do more work than we have to. So, and I talk about getting tunnel vision all the time, and that was a prime example of me getting tunnel vision. I was so focused on using the trig identities, I didn't step back and say, oh, well, duh, tangent times cotangent, they're reciprocal, so it's going to be a 1. So we'll say that I made that mistake on purpose. Secant is 1 over cosine. Cosine, 1 over sine. So this is sine over cosine over cosine over sine. And you can Bojangles. And you're going to get sine squared over cosine squared, which is tangent squared. And notice you put your square on your tangent, not your x. This one is unbalanced, which was in our bag of tricks. So I'm going to make 1 balanced and pull the excess off. And so that's going to be tangent times sine. And at this point, I would love for you, again, once we brush the summer dust off, for you to be able to do this step in your head and just look at this and say, well, one of these sines and the cosine would give me a tangent, and I would have an extra sine left over. Sine plus cosine, some of you may be tempted to go Pythagorean on this guy, but nothing squared. They're already in terms of sine and cosine, so I can't go any more basic than that. So I'm going to pull this apart, and the only reason I can pull this apart is because there's one term in my denominator and multiple terms on the top. So I'm going to have sine over cosine plus cosine over cosine. And again, if you can do that step in your head, that'd be great. This is just going to be tangent plus 1. I'm going to pull this one apart also. So I'm going to have tangent over cosecant plus secant over cosecant. Tangent is sine over cosine, and cosecant is 1 over sine. I'm going to go ahead and Bojangles that. And so that's going to give me sine squared over cosine. Now let me do this side. Secant is 1 over cosine, and cosecant is 1 over sine. I'm going to flip it, and sine over cosine, which is, well, I'm going to leave it as sine over cosine, because now they have a same denominator. So sine squared plus sine over cosine. I'm going to GCF a sine out, maybe. Oh, yeah. And then I can let this, because they're both single, be a tangent. And we talked about in pre-cal that there's more than one way to get to the solution. So if right here you said, well, you know what, this is tangent and this is unbalanced, but sine over cosine, one of those would be a tangent, and then I would have an extra sine, you'll see that we're at the same place. All you have to do is distribute that. So again, remember there's more than one way to do the problem. Okay. Tangent over cotangent. Well, I'm going to try to see the big picture here. Cotangent on the bottom is the same thing as a tangent on the top, so that's tangent squared. This one I'm going to go sines and cosines. Those are going to cancel. I'm going to get sine plus sine, which is 2 sine theta, not sine squared. This one, I'm going to go sines and cosines. And that gives me a common denominator. And 1 minus cosine squared is a Pythagorean, and that's sine squared, which is sine of y. I bet this is very similar. Sine over cosine times sine over 1 plus cosine. So sine squared over cosine plus cosine over 1. So I'm going to give him a cosine over cosine. So sine squared plus cosine squared over cosine, which is 1 over cosine because of the Pythagorean, which is secant. And again, I know I'm going fast. This is a review, but feel free to pause it if you need to digest it. For this one, I'm going to look at kind of each term and try to clean it up. So cosecant is 1 over sine, and secant is 1 over cosine. I'm going to change colors so it separates it. So this is 1 over sine cosine. And this is sine, secant is 1 over cosine. So this is sine over cosine. So then I'm going to give him a sine to make this a common denominator. So 1 minus sine squared over sine cosine. 1 minus sine squared is cosine squared. And then cosine over sine is cotangent. There you go. Okay, so again, I know that was fast, but again, it was a review. So feel free to slow down, go back over it. You should have a pre-cal notebook or chapter full of these that you can go practice if you want to. But again, these are going to be a step in a calculus problem, and it needs to be kind of quick and automatic.